Thank you all so much for your patience. So today I'm mostly talking about the career paths you can take as a physics degree holder. I guess part of it is advice for you on where to take your career if you're an undergrad, graduate student. A big piece of advice I would give is don't be 15 minutes late to your talk, but lessons about parking. So before I start, there's a survey about the talk. I'll also have this up later. If you could pull that up and fill it out, it's very short. I would appreciate it. So before I start, can I get like a quick show of hands of who here is a physics major? Most people, I'm guessing. Okay. So I'm gonna talk first about where I came from. I was not a physics major. I was a mechanical engineering major, but then I got involved in the physics community in grad school. And so it's kind of my second home now. Then I'm gonna give some examples of careers that physicists have had and where you should take your degree, some statistics on overall what kind of career paths do physics majors take, and a little bit of job search advice at the end of that stuff. So I started off as a mechanical engineer. I did a bachelor's and a master's at the Cooper Union, which is a tiny school in New York that nobody's ever heard of. At first I was not the best undergrad. I was not very interested in the material until I took a fluid mechanics class. And that was kind of more mathematical and more physicsy. And that really caught my attention, that I could have these, beautiful equations of fluid motion that would give me, amazing simulations and also some very interesting experimental results. So I did a master's thesis on how to measure fluid flow. If you've ever heard of particle image velocimetry, it's basically a technique of trying to figure out how fast a fluid like a water is flowing through a tube, or how fast air is flowing over an airfoil, something like that. So after that, I thought, well, I like research. I'm going to continue on to a PhD. So I did my PhD at Georgia Tech in David Hu's group. And my thesis there was actually on the collective behavior of magnets. So these little blobs that you see on screen, I measured how thousands of them would behave as if they were an active material. So, you put some water in a bowl, it's not flow. You put some magnets all in a bowl together, they're going to move around a lot. And so I studied how, if they were a fluid, what would their properties be? If they were a material, what would their properties be? And then I got involved in some of these writing for a soft matter blog. I got involved with the division of soft matter with the American Physical Society. And so kind of that connection to the physics world is, that's where that connection started. So that took me another like 5 years. And now I'm here at the Biofrontiers Institute in Uri Lab. And I study how bees self-assemble into swarms and what kind of mechanical characteristics these swarms have. Which, if you are an undergrad and you're interested in doing research with bees, send me an email. We're always looking for good helpers. So here at Biofrontiers, we put together a CT scanner from an X-ray machine and some materials we had in the lab. And then now I'm reconstructing like what all of the positions are of the bees within that clump of bees. And now that they're hanging off of that structure. So how do they not all down, and how do they react to, for example, the temperature changing and the bees needing to stay cool or stay warm? So it's similar to my PhD work. I use a lot of the same skills, but I've also learned some new things, like I've never worked with X-ray CT before, and I've never worked with bees before. So that's been a whole learning process. So part of this, I got involved with communication. So I write and edit for a blog called softbytes.org. We cover everything that is soft matter related. So really the physics of anything squished, I would describe it. If you can think of it, if it's free, it counts as soft matter. So if you're interested in like learning about the kind of recent papers in soft matter that are written in a way that anyone can understand, even like I can understand, like a paper on glasses or something, but I can definitely, pull up one of our articles and say, oh yeah, this makes more sense now because it's written in a more accessible language. Also, I'm the student representative and a student affairs committee member of the Division of Soft Matter at the American Physical Society. So we have a plan for the future that if you are interested in soft matter, follow the Twitter page and you'll hear all about them. A little more self-promotion there, but I think it's going to be really exciting. And how I got to all of you here is I applied for this career mentoring fellows program, where they kind of give us guidance on how to mentor students. And as part of it, we do this talk. Also, some more pages to check out are the Division of Biological Physics, DBio on Twitter. Also, I'm a little bit involved with them and feels nice to throw in a link to them as well. So then, I'm not really a physicist. Now let's get into like, what do people with physics degrees do? And the answer is, again, anything. These are just some examples that were given to me as part of the slide deck. For example, this is a process engineer who, a lot of physicists decide to go on to more of the hands-on side. So after a PhD, she decided to start working on engineering. A director of data science. I think an important thing, one of the things that I like about this example is that she is open about having had a learning disability and discovering that she likes physics. It's a good sign that there are people with learning disabilities, physical disabilities in physics, and many of them go on to having very interesting careers. Professors, always academia is an option. Product development, many other examples, education, business. There are countless directions you can take your physics degree. So me personally, before I get into all the numbers, my lessons learned so far from looking at the careers of other people that I've met and where I've gone, first of all, is follow your curiosity. So there's so many career options and you're not limited to just the things that you learn in undergrad. I know physicists who became doctors, who became involved in nonprofits that aren't even related to physics. A lot of patent lawyers. There's just so many options besides the one I showed you today. Another thing is science is really frustrating. So if you do research, you will be banging your head against the wall. And it's always good to keep in mind that the struggle is part of the process. And the last thing that I want to point out is physics takes up a lot of your time, science takes up a lot of your time. Fight to have a little bit of sense of self and things outside of physics. For example, that's my dog, Tammy. We go for walks in the evening and it's time when I'm not thinking about science. Highly recommend the little brain break. And I could go on about this sort of thing forever, but I'm going to show you some statistics on degrees in physics. So overall, around 8,500 physics degrees are awarded annually based off of 2018. So the data I'm going to show you is all from this link. I would recommend checking it out. They have statistics on anything physics and also general STEM degrees that you can think of. So out of these 8,500 bachelor's degrees, about half of them will go straight into the workforce. And before I show you the stats on that, I just want to bring up the issue of underrepresented groups in physics. So over time, recently, the percentage of physics bachelors compared to women has been increasing significantly. And so the situation for women is getting better. Other underrepresented groups, it's not as great. And it's something that we really have to keep in mind, the diversity of our workplace, of our lab groups, and so on, making it easier for underrepresented groups to actually have a foothold in this area. So once you get a bachelor's, what do? 52% will go get a job in the workforce, mostly in the private sector, so in industry. A good 30% go on to doing graduate study in astronomy or physics, and then others go into graduate degrees in other fields. So if you want to make money right away, you will want to get a job in the workforce immediately. Your options, mostly people entering the workforce get jobs in engineering, programming, general STEM jobs where they'll be using a lot of the same skills that we learn as physicists, but just in a slightly different context. And this was on the bottom you see, even in the non-STEM fields, you do end up solving technical problems. So your degree, even though you're not using like the specific like Schrodinger's equation that you'll learn in class, you'll still be using the same mental tools. So if you decide to go on for a graduate degree, you can either get a master's as your final step, so you get a master's in physics and that's it, and then you go get a job, or you can get a master's on the way to getting a PhD, because on the way to getting a PhD, you fulfill a lot of the requirements for a master's. So that's what those different lines mean. So master's on route to PhD is the people who decided to get a PhD, and then on the way there, they decided to just check mark the box for I got a master's degree. So we'll look at PhDs later. Right now, I just want to talk a little bit about only master's degrees. So masters exiting from PhD departments or only master's departments. And so that's a little bit less than half of the general group of people who get masters in physics. And I don't know how much of this you all have absorbed, but there's a kind of a general idea, that bias that people have, a preconception that if you're getting a PhD and you get a master's, that's it, you've mastered out, you've failed. But that really means is that you succeeded at getting a master's, and that's a huge accomplishment. And as I'm going to show you, there's a lot of different options for to do with a master's degree in physics. And in engineering, I think with a master's is even more common. So again, most people will go into the private sector to be employed by a private company or something like that to work on products and so on. There's also options, people go on to teach at colleges, high schools, work in government labs, but the vast majority go into the private sector. So this is, I think, this is only for master's degrees, but it's a good graphic for kind of what skills people use. So whether you're in the private sector or you're in academia, you're going to be using a lot of very similar skills. Problem solving, programming is a really good skill if you're a physicist, I'm sure you know by now. Design, you use your physics knowledge. Even if you don't stay in physics, like in academic physics, you use a lot of your physics knowledge according to the poll of exiting physics masters. What skills have they used in their jobs? And there's a lot of overlap. Basically, if you are in academia, you will still be using those skills. And another important part is your social skills. So science doesn't happen in a vacuum. Nobody works by themselves. At this point, most science happens in teams. Even in academia, my PhD wasn't just me sitting in a lab for hours and hours a day. I had other lab mates that I worked with. I had collaborators. I had undergraduate students who helped out with a significant portion of my work. And so teamwork is very important, whether you're in academia or whether you're in industry. Technical writing, I know a lot of us go into physics or STEM because we don't like writing, but learning to communicate your ideas effectively goes a long way to help you be able to first make the thing that you're trying to make, but then actually explain to people what it does, how to use it, what might be wrong with it. Managing projects, again, even as a PhD student, I found myself doing a lot more management work than I expected. And that's kind of what you would expect working in industry, but also it's very present in academia, managing people, working with clients. Everybody has a funding agency that they're trying to satisfy in academia. So you always have somebody that wants something from you. The goal is to make that something that you actually want to work on. Public speaking, again, in academia, you actually do, I think, a lot of it because you end up giving all of these talks. And budgeting is another important skill that they don't teach you in school, but you will have to pick up to either write grants if you're in academia or to manage your projects if you're in industry. So let's talk a little bit about PhDs. Our number of PhDs is rising very fast over the last 2 decades. So the curve is the total number of physics PhDs up to 2019, and then we have that split up by US citizens and non-citizens. So overall number of physics PhDs is going up. Where are all of these people going? Once you get through this, 5, 6, 7 years of very hard work, what do you do next? And this is a question that I also had very recently. I guess still I'm kind of trying to figure out. So out of the 1,800 physics doctorates graduated between 2015 and 2016, and these numbers are kind of all over the place because of how these surveys were just done at different times, but the trend kind of stayed the same over time. So some number of them left the US, and let's say 1,600 stayed here. So what happens to these physicists who go on the job market? So about half of them will go into postdoc positions. Like that's where I am right now. It's a temporary job in which you spend maybe 2 or 3 years working in a lab, continuing to do research, publish, and building up your publication record and your scientific, your scientific brand, essentially. So it's not permanent. After 2 or 3 years, you have to go and find a postdoc or a permanent job, ideally a permanent job. So out of the other half, about 40% go into potentially permanent positions. So either that's a full-time job in industry, or it's, if you were very lucky, a job in academia, like a tenure-track professor job. But as this graphic shows, most people, this is 1 year after the PhD, and out of the potentially permanent positions, many of them went into the private sector, industry jobs in engineering, computer science, so on. So this is 1 year after. So this rather shows that 15 years later, the split is very similar, that 43%, 30% stay in academia, while a lot of people end up getting into those business industry jobs. And that's for a number of reasons. Definitely, the demand for academics, tenure-track faculty is unfortunately not very high. So in 2016, there were about 300 new tenure-track hires out of 1,600 PhDs who were looking for jobs. So those numbers aren't very good for if you're getting a physics PhD and you really want to get that tenure-track job. There's going to be a lot of competition, as with everything you do, but here it's, I think, a goal for many people getting PhDs, and it can be very, very hard. So definitely something to go for if you're very passionate about it, but also keep an eye on, other opportunities that might be available for you. And again, like most people who want those tenure-track jobs, you can really only get them with your PhD. And even with a total of about 500 hires, there's still a lot of PhDs graduating who go to do something else. So what do? Industry is obviously the answer. Over the last, 20 years or 30 years, the percentage of physics PhDs going into the private sector has been more or less consistent at about half. So they go into finance. I had an amazing physics professor in college who decided, for various life reasons, to get a job with, I forget exactly what it was, but it was some kind of programming in the finance industry, and he says that he loves it. It's challenging every day. So that, finance to some people sounds like selling out, but it can actually be a very fulfilling career. Government contractors, computer science, engineering, STEM, other STEM fields. All of these options, you will do research, you will have a say in what research you do. In academia, you have more of a say in what you do, but then there's some other trade-offs, such as not having enough funding might be a trade-off because academia doesn't pay as well. Or it can be, the tenure track can be a lot more time consuming than if you have your entry job and you spend your time, you have a more set hours than you would in academia. But either way, if you want to do research in any of these fields, as a physics PhD, you probably will have a good option too. So now I know everybody wants to know how much they're going to make. So I put a couple of extra slides in here on that. So with the physics bachelor's, so this is all starting salaries. Physics bachelor's, your best, if you want to make a lot of money, option is going to be in the private sector, staying in STEM and working in engineering, computer science, all of those fields that I brought up earlier. Government labs are also a great option. Deep government labs who I've talked to tends to be very happy with their work and also with their salaries. And then I think one thing that is very sad about this is how little high school teachers earn. That's not right. So then if you get a master's, again, private sector, you will be paid more. And then if you get a PhD and you think, I have a PhD, I'm going to make a lot of money. Well, so your starting salary is definitely going to be higher if you have a PhD. Most likely going to be higher. I wouldn't say definitely. But if you want to stay in academia, that's not necessarily true. Getting a PhD might not be the best way to make a lot of money if that's what your goal is, and that's a perfectly good goal. So the idea, basically the point is, if you have a good salary, you don't need to go through many years of grad school where after that you won't get paid as much. And another thing that I don't have on my slides, but I want to bring up is, if you are in grad school in STEM, if you're doing a PhD, you should be being paid to do that. It's not a very high salary, but a lot of people think that it's kind of like a bachelor's where you pay the university to take credits. And that's not, you do get a stipend that is close-ish to a living wage, depending on the school. So don't let that particular thing scare you away from grad school too much, only a little bit. So that's kind of the statistics of what people do with their degrees. So now, like, you're thinking, well, what do I do as a physics undergrad or otherwise STEM student? So this is some suggestions that APS provides. So think about what you do, what you're good at doing, and what you enjoy doing. So for example, I love working in the lab. And I know that if I were to get a programming job, I would be missing the lab aspect. So when I was finishing up undergrad, I decided, well, a lot of my friends are going into computer science. I don't want to do that. Also think about your working style. Do you like to work with other people? Are you more independent? Do you want to have a set goal for your project and it's done? Or do you like the more open-ended approach where you explore different options? So I will say that at this point, even if you do a PhD, you will still be talking to people. I was surprised. I thought I would be sitting in a lab most of the time, not talking to anybody, but I actually ended up going to so many conferences and giving lab tours to a lot of people and just generally talking science to a very wide range of contacts that I have now. And while that might be not your thing if you're more introverted, you kind of get used to it and it can be very valuable. But I think there is more potential for collaboration on the industry side. And another similar difference between academia and industry is going to be, well, if you are more goal-oriented and you want to have this one project that you are finished with, industry is a good way to go, because in academia, projects can kind of drag on and go into new directions, and it's more exploratory. It can be very satisfying, but also a little more frustrating, because sometimes you end up at a dead end and you think, well, what do I do now? It's something to think about, like, which kind of frustration do you prefer? And we do have deadlines in academia. People have the stereotype of the academics sitting in their office just doing all day, and we do actually have deadlines, unfortunately. So, keeping a notebook or a document or just a log of these things is probably a good idea. I never did that, and I probably should have. Maybe it would have made things a little bit easier to figure out. And one thing that I would recommend is documenting your skills. So you learn how to use a particular piece of equipment, or you did a really good job of managing a team project. Keep a log of, keep a very long document of these things, so that you have material for your resume or your CV, so that in interviews, when they ask the inevitable question of, what was your greatest teamwork experience, or name one time that your project didn't work and how you could have done better, you have a long list of examples to draw from, and that just makes you more competitive. And then also, it's a good way for you to kind of know yourself of what is it that you are good at doing, what is it that you would prefer to be doing. Kind of like a lab notebook, but for your own brain. APS has a lot of resources. So this is, if you get anything out of this talk, this would be, these links are good. And I don't know if if this is being recorded, you can look it up. So the APS 2021 career guide, it looks like that little logo with the arrows, has a lot of opportunities, advice from professionals, list of companies. I think APS also organizes career fairs sometimes. They had a virtual one a couple of months ago that I went to, and it was very helpful, even though I'm not even looking for a job. Another general piece of advice is career fairs are good even if you're not looking for a job, because then you get to meet people and know what kind of work is being done, who they're looking for. And that can guide you towards your next year, maybe when you are looking for a job and you want to more directly focus your search. SPS Career Toolbox has a lot of these a lot of similar content, also a list of common job titles, job searching tips, resume tips. Really, you can look up, there's a lot of resume tips that you can find, and a lot of it contradicts itself. So just do what works for you, I think, in that regard. But there's a lot of material out there if you wanted. And yeah, the APS Careers website, I think I mentioned it before, but they have a job board. The physicist profiles that I showed you, kind of skipped over earlier, I would take a look at those, because they can be really a good source for what you might want to, I didn't know you could do that with a physics degree, that kind of thing. Examples are good. APS has webinars also. There's an upcoming one on physics for society and how physics can have a role in the big societal challenges that we have today. So if that's something you're interested in, I would look it up, and also just keep an eye on that. Building your network is important. LinkedIn, if you're in industry, is very big. I do not understand LinkedIn. Don't come to me with LinkedIn questions, because that website confuses you. But if you're in industry, you will get used to it and you will use it very well and make many connections. If you're in academia, a lot of the academics post jobs on Twitter, which sounds kind of strange. I was surprised, but it's actually been a really good networking tool. If you find the right professors and the right students to follow. Attending conferences, mixers, so on, also very good. Again, building your network is the most important thing you do. And I bolded that because I think that's kind of the thing that helped me the most, is finding internships, volunteering opportunities, research opportunities. If you try out all of these different things, like get an internship in industry, get a summer research opportunity, or even like during the semester, work in a lab, see what that's like. At the end of it, you will have a much better idea of what you like doing and where you would like to be working in the future. There is a mentorship program through APS called Impact. If you want to go into industry, that's a good resource. You can also ask. If you have a good relationship with a faculty member, you can always ask them to connect you to other students that they know who graduated and are doing something you want to do. And attend informational interviews. I don't know, I would definitely like reach out to contacts and ask them what their job is like. I feel like whenever I did that, I always did that through email. I never like actually like arranged an interview, but if that's a thing, then that might be a good idea for you. And if you're not a US citizen, a lot of jobs have a US citizenship requirement, particularly if they're dealing with defense. So that is an unfortunate limitation, but APS has a lot of resources for if you're an international student, where can you get a job? How can you navigate the visa process? All of these links or if you just like go on the APS website and go into their international affairs website, that would be a really good place to start to try to find out for navigating all of this. So summarize, hundreds of physics degree holders go on the job market every year. Out of them, about 40% will go into academia over a long period of time. Most will go into the private sector. They will work for engineering firms, finance firms, programming jobs, and government labs. Many options for careers outside of academia in physics, and don't feel limited by just the degree that you have. You can start preparing now using all of these resources that I can provide links to, or if you have anything else that you want to ask me about all of this, and I know this was a lot of material that I went through very fast, so if you want more details, just send me an email. I know, follow me on Twitter. If I check it, I will definitely reply. So definitely like expand your network. I'm now part of your network, kind of. The connections you make are just as important as the skills you learn. And I think one final thing from me, not on this list, is do the physics that you're really interested in or the science that you're really interested in, and then do other things that you're really interested in. It will make your physics life better and your non-physics life better. So please fill out my survey. If you're interested in research or anything else, please feel free to contact me. And I went through this quickly enough that I can answer some questions. So if there's anything else you want to hear about. Yeah, thank you all for listening. And I think there's going to be refreshments out on the lawn. Is that right? Yes. Yes. Sorry. The question was, what do I know about physics majors who went into computer science? So I think through a lot of your classes, or a lot of physics majors through their classes and their projects end up learning a lot of different programming, whether it's through MATLAB, Python, C, and these, it's the same programming that web development companies and general software companies are also interested in hiring people with. So one of my best friends with an engineering degree, got a web development internship, and he loves it, and he just stayed at the company. And it happens a lot where it's the same puzzle solving skills that I think a lot of physicists love to use. Yes. So the question was, how do you use your computer science minor or computer science knowledge to further your physics? So a lot of what I end up doing, like half of my work is being in the lab and collecting data. The other half is programming to analyze that data. So for me personally, I use all of my computer science skills just as much as I use my experimentation skills. Right now, I'm trying to process like hundreds of CT scans that I took this summer. That's not going to happen if I'm just, processing them all individually, one by one. And then a lot of people will do, and that's just me. A lot of people who work in physics research are computational physicists. So their entire job is just to write simulations of physics problems or engineering problems or so on that the simulations help provide an answer to. So it's one of the best skills you can have. Yes.
Is there much overlap between research in engineering and research in physics?
The question was, is there much overlap between research in engineering and research in physics? And yes, I think so. For my two sort of areas, like the soft matter side and the biological side, we have, even though it's the American Physical Society division for these things, a lot of the participants are engineers, physicists, and they're all working on the same problems. The real thing isn't like what degree you have, it's the skills you learn and how to use them. And then I don't know as much about this, but from what I've heard from people in astrophysics, again, very similar skills, but also a lot of engineering goes into building telescopes and the equipment that used to collect data for the astrophysicists to analyze. So plenty of overlap. And I think there was one more question in the back. Yes. That is a really good question. I think I mentioned before, if I spent my entire day programming, I would be not happy. So at least with, I do like some amount of programming, but also in academia, I do a lot of hands-on work, which to me is personally very satisfying. Another thing that I enjoy doing and that a lot of people find a good career in is either technical or scientific or outreach writing. So if you enjoy writing or communicating, there's a lot of jobs in education, doing outreach, that sort of thing. You don't need to program as much and you still get to be involved with the science. And I think generally with a STEM job, there will be some amount of programming, but how much will depend on kind of where you take it. Yes. Yes. The question was, I mentioned earlier that one of my friends became a medical doctor, and what was her path to doing that. So this particular friend, we were best friends in high school, and she always wanted to become a doctor, but she wanted to major in something other than biology, and she thought that physics was really interesting. So it was a way for her to continue on the career path that she wanted, but also to find out more about a subject that she loved. I know some other people who became, this is on the engineering side, but I think it would be a similar situation for physics, who were working on their engineering degree, halfway through realized that they're interested in biology and they want to pursue medicine. So they took the couple of extra classes like organic chemistry and so on, required for a pre-med degree, and then applied to med schools. So really I'm not the best, obviously, source for this, but the main thing is that you take the required pre-med classes and you do well on your MCATs, and then you kind of go from there. It doesn't matter what you are, you can be a psych major. It doesn't matter. I guess psych isn't that weird, but it doesn't matter what major you are, is my point for many of these career paths. Thank you very much for listening.